The oceans are undergoing change. At the moment we're seeing change, two parallel streams of change. On the one hand, the ocean environment itself is changing. That's most obvious, of course, in the Arctic, but at the same time, the way in which we use the ocean environment is also changing. And it's the confluence of these two types of change, environmental and changes in use, which creates the different patterns of risk that MEOPAR is trying to both characterize and anticipate and give the scientific background for guiding response. What our job in MEOPAR, is to mobilize science and the strengths of our academic community in Canada, is to mobilize those brains really to finding solutions to these challenges of the future.
We're looking at long-wave satellite radar technology to improve the ability to identify ice types and potential ice hazards in the summertime. It's really groundbreaking research because we haven't really tested this radar technology yet, so we're really excited to do so.
Canada has a huge Arctic coastline. It stretches for a really long distance, and it's really hard to observe things that are going on there. It's hard to respond if there's any sort of an emergency. What we're trying to do here is create kind of a model that we could use where we have infrastructure in a community and capacity in a community to observe certain parts of the ecosystem and to respond if there's something like an oil spill happens.
We're working with the Atlantic Condor, which was built in Halifax actually, and also with another company that's here, and then they build holographic microscopes, so it's 4D in-water imaging. And so we're working closely with them we're basically going to deploy their instrument on the Atlantic Condor to follow the phytoplankton. And that way we'll be able to really accumulate a lot of data to be able to see what is actually going on, what's the variability in the environment, when are the good algae there, when are the bad algae there, and so on.
We're bringing together government, industry and community and trying to solve a major issue in the Arctic right now. So the big question is, how do we best manage Arctic shipping in a way that respects local people, that supports the industry development, and that encourages economic development in a sustainable way.
Over half of BC's population is centered on and around the Fraser River estuary. So that means we have heavy urbanization, we have a lot of pollution in terms of runoff from the city of Vancouver, from industry, from agriculture. We have heavy fishing pressure in the Fraser River. And so that puts a lot of pressure on the natural assets that are in that area. We're going to lay out the costs of various management actions that could be taken, the benefits, and the feasibility. And those three things are really important for motivating resource managers and decision makers, because they give them very clear information about what the return on investment will be of the different actions that they could take. So this project effectively could serve as a template for how we move forward to start making more informed, more intelligent decisions about how to manage our natural resources.
So we take the images that come from our drone and we create a video game that allows us to raise and lower the sea levels as if there was a storm surge coming. And it allows people to look at what types of infrastructure on land might be affected by this coastal storm surge. The money that we're receiving from MEOPAR is helping us on some First Nations communities, and they're using that to help in redesigning their emergency response plans under future climate change.
So my grant is specifically to monitor marine plastics in Canada's north. Plastics are in every ocean in the world. 92% of them, meaning almost all of them, are smaller than a grain of rice, 5 millimeters or smaller, which represents real problems for trying to track them. So we're building technologies, 3 different technologies. Biological monitoring, surface trawls, things that go along the surface of the water. And then we're also trying to figure out, how do you monitor shoreline plastic when there are rocks and ice? Because there are no protocols for that. So the point of this research is trying to just figure out what the problem is so that we can figure out how to address it. Cleaning up is generally thought to be not the solution, right? It's a stock and flow problem. It's kind of like trying to bail out your boat before you've plugged the hole. So we're trying to see what's in the boat so that we can figure out where the hole is and plug it.
We just want to get microbiology on the radar because we think that these oil-eating bugs have a lot to offer, and there's probably a lot of nuance where we can sort of dig into that and really understand that in detail. That'll be beneficial for Canadian industry, Canadians, and super interesting science. We're also really focused on understanding the potential for the bioremediation and the cleanup of an oil spill if it were to happen.
Our project will allow us to install sensors aboard of the ferries, and these sensors are basically small satellites, collect exactly the same information as the satellite, but without the interference from the atmosphere. So the idea is use as much information as possible from the field and upscale that to validate satellite data so we can have this big overview of what's happening in the region. At the end of the day, we will have better satellite products that can describe in a spatial-temporal domain the status of the environment, in this case the Salish Sea.
In MEOPAR, we're extremely grateful for the opportunity that's been presented to us by Irving Shipbuilding for demonstrating what we can do together through this partnership in terms of mobilizing research talent to address, anticipate, and we very much hope find solutions to some of the challenges facing us on all of our coasts in Canada, to the risks and changing hazard patterns of the ocean environment. It's a model that we'd very much like to see replicated in the future. We can see the translation of a shipbuilding project of great importance to Canada, but also the impact on research, on training of students, which will have impact not just on Canada, but I think many of these projects will have worldwide impact. So I'm kind of excited about that.